In section 7.2, we're going to look at systems of linear equations with three variables. When we say three variables, we mean instead of just an x and a y, we'll have an x, a y, and a z. So most of our answers will actually look like points where we have an x, a y, and a z. So our points will have three parts. Sometimes these are called triples. And these are used a lot in real life because the 3 points x, y, and z are able to describe things in 3 dimensions. In our first example, they say, is the following triple, is this point with an x, y, and z a solution of the following system of 3 equations? Now, remember when we did this back in section 7.1, we had to make sure that our point, which was just an x and y then, worked for both of our equations because we only had 2 equations. Now we have 3 equations, so we have to make sure our point works for all 3. If it doesn't work for even one of the equations, this point is not a solution because the thought is all 3 of these equations have to pass through this point for that to be a solution to the whole system. So we'd start by taking the first value, the -2. Again, we go in the same order, starting out with our x. So we'll plug in a -2 for all of our x's. So we'll plug in a -2, a -2, and a -2. And then we'll plug in all of our y's. We'll plug in a -1 for all of our y's. So let's see. And we'll plug in, let's see, what else? We've got a 3 that we're plugging in for all of our z's. Notice there's only 2 z's, that we need to plug in that 3 for. So let's take a look at our first equation. On our first equation, notice we have a -2. And then be careful. We had a minus a -1 when we plugged in our -1 for the y. That would give us a +1. And then we had a plus the z, which was 3. And that whole thing is supposed to equal 2. Well, let's double check. Well, -2 plus 1 is, let's see, -1 plus 3 is that equal to 2? Absolutely. So at least for the first equation, the point is a solution. Now I would need to check my second equation. For my second equation, I had my 3 times my -2 that I plugged in for my x, minus my 2 times my -1 I plugged in for y, plus my z, which was 3. And the question is, does that equal? Well, that second equation is supposed to equal -1. Well, we have to do all of our multiplication first. So 3 times -2 is -6. -2 times -1 is +2. And keep on going left to right. -6 plus 2 is -4 plus 3. Does that equal our -1? Well, -4 plus 3 does equal -1, so we're 2 for 2. Now I just need to check this last equation. The last equation said that we had our x value as -2 plus our y value was plugged in at -1. And the question is, does that equal -3? Does -2 plus -1 equal -3? Yes, it does. So we're 3 for 3. All 3 equations are satisfied for this point, which means, is it a solution? Yes. The point holds true for all 3. Had it been off for even one of them, we would have said no.